Here's something that may surprise you. Air does not mix very well. We often think of air as a continuous fluid with no inner boundaries, but it actually comes in chunks, kind of like stuffing. We could see one piece of air next to another with completely different properties, and a very sharp boundary between them. In fact, we see this a lot. Let's say we have a large landmass here. Might as well be the United States. I know it's horrible, but I don't really know anyone that could draw a good United States just without looking at anything. Say, alright, and this is Canada up here. Canada, US. Let's say we have a cold front coming down from Canada. That means we have a very cold and dry air mass here pushing its way southward. So this is not just like a wave of coldness coming down by, coming into contact with the air next to it. Once the air mass is, advanced further, like, down here, the air that was from Canada, the actual air molecules, most of them are the same air molecules you'll see there. It's the actual chunk of air that's literally pushing through. There is some exchange of mass between the front, but this is, a pretty good approximation to say that a frontal system is literally just a large chunk of air. Now let's go to a much smaller level, let's say a few hundred feet across, or just on that order of magnitude. And let's switch to the vertical dimension. So this is the ground and this is up. I might actually need more room than that, so I'm going to do the same thing down a little more. Okay, so that's the ground, this is up. Now let's say we have a chunk of air here, or also known as a parcel of air. It's going to have certain properties. It's going to have a certain temperature and a certain dew point. Let's write that out. So it's going to have a certain temperature and a certain dew point. We'll write that as TD. And remember, the temperature is going to tell us how much water this parcel can hold, and the dew point is going to tell us how much water is actually being held in this parcel, how much water is actually in there. So yeah, as we discussed in the last video, the temperature, that's telling us the capacity for water content in the parcel. The dew point is going to tell us how much water it's actually holding. And let's say this parcel is somehow pushed upwards. And there are many ways that this could happen, and we'll discuss those in a bit. But for now, let's just assume it was magic. So as this air parcel moves upwards, what's going to happen? Let's say the top of the atmosphere is, way up there. The top of the atmosphere is no definite boundary, but the top of the atmosphere is up there, and so we have a new parcel here. Well, it's the same parcel. It's just it's in a higher state now. There is less air above it at this point than there is at this point down there. So basically that means it's under less pressure. Think of, if you're swimming in a pool and you're underwater and you're in the deep end, your ears might pop because you're under a lot of pressure, but then when you get closer towards the top, towards the surface, you're under less pressure. It's the same kind of thing. Air, of course, has weight, so there is less pressure higher up in the atmosphere. So yeah, once this parcel is higher, it's lifted up higher than it is on the ground, it is going to have a lower pressure. And you might have learned in chemistry that the pressure times volume of air, or any fluid, I think it's any fluid, but definitely air, is proportional to the temperature. So as pressure goes down, temperature goes down, because those are proportional. So what that means is, as this parcel as this parcel rose from the ground to higher up in the atmosphere, it cooled. So what happens as it cooled? Well, the actual water isn't going anywhere yet. So it's going to have the same amount of water, right? So the actual water content is constant. But because it cooled, the capacity for water will have gone down. And so if this parcel is going to keep rising, let's say it goes up another level here, eventually its capacity is going to keep shrinking and shrinking until the capacity of water has shrunk to the actual water content in this parcel. So now, let's say it's at its maximum limit. The temperature is cooled enough where its capacity has reached the point where the air is holding as much water vapor as it can. So what if this parcel wants to keep going up? Well, now you have excess water vapor that the air can't hold. So it will condense and form a cloud. In the next video, we'll take this idea a step further and begin to look at soundings.